So before I get started, I'd like to go over your last assignment, which was Chapter 3, Section 5. And it had you do a couple of problems where you had to basically, for example, number 21. So I'm going to draw your attention to number 21 and then number 22. In 21, you were given the graph y equals sine of x, and you were asked to graph the derivative function of y equals sine of x. And when you did that, you should have noticed that this is a very familiar function. And so we can say that if we take the derivative with respect to x of sine x, then what we're going to get is cosine x. Okay, and then over here we had a similar problem where they gave you the graph of cosine x, and you had to come up with the derivative function of cosine x. And you should have noticed that when you did that, so when you took the derivative of cosine x with respect to x, you ended up with negative sine x. So these are two very important derivatives that I would memorize, unless you wanted to prove it every single time by graphing the original function and then graphing the derivative function. That might get pretty tedious. So you definitely want to memorize that the derivative of sine x with respect to x is cosine of x, and the derivative of cosine of x with respect to x is negative sine x. All right, moving on to 3.7. 3.7 is derivatives of composite functions. Or we might call that the chain rule. This is going to be very important that you're able to do the chain rule. Our essential question: how do you use the chain rule? To find the derivative of a composite function. So let's remember what a composite function is. So a composite function is a function made up of two or more functions. So this is composed of 2 plus functions. So if you remember, like your f of g of x, f of h of x, f of g of h of x. So we worked with those quite a bit in Algebra 2 and Pre-Calculus. Let me just give you an example. So maybe I have a function that is sine of x squared. This is actually composed of two functions. There's a function within the sine function. Okay, so we really have this outside function, which is the whole thing here. This is our outside. Okay, and then we also have this inside function. So the outside function we'll call sine of something. Okay, there's some input there. Okay, and then we also have this inside function, which happens to be x squared. Okay, so this is an example of having a composite function. So the problem is that when you do this, you're going to have to take the derivative of the outside function first, and then take the derivative of the inside function, and then you multiply them together. Okay, so for example, if I was to take the derivative here, well, the derivative of this outside function, sine of whatever, if I take the sine of any other inside function here, basically the derivative of sine of anything is going to be cosine of whatever that anything was. Okay, so I keep what I originally had as my inside function, I keep that there. Okay, and then from there, I now take the derivative of this inside function and I multiply it. So I end up with my final answer being, and I'll bring this out in front, 2x times cosine of x squared. So that's one way of looking at it. Another way of looking at it is a thing called U-Substitution. So when in U-Substitution, you let the inside function equal u. Okay, so this gets a little bit confusing, but some people like this better, so I'm going to go ahead and show you how to do this. So once again, I'm going to start with my original function here, f of x equals sine of x squared. Okay, so x squared is my inside function, so I'm going to let u equal x squared. So then what happens when I take the derivative of u with respect to x? Well, the derivative of u with respect to x is basically just 2x, right? If I take the derivative of x squared, that's just 2x. Okay, so instead of having this inside function be x squared, I've now let it be u. So I can rewrite this as sine of u. So then when I do f prime of x, I take the derivative of sine, which is cosine, leave the inside function alone, so it's cosine u, and those parentheses are arbitrary. So I like them because they show me what my inside function is, but you do not have to have them. Okay? So I'm going to do the derivative of the outside function times the derivative of my inside function, which is du dx. And now I go back through and I substitute. So u was originally x squared, and du dx, when I took the derivative of u, happened to be 2x. And once again, I'll move things around so it looks a little bit better, so that I know that 2x is not part of my input. Okay, so basically what I've just used is I've used the chain rule two ways. Okay, I used the chain rule here without using U-sub or U-substitution. And then I use the chain rule again, this time using U-substitution. It's up to you guys how you want to do it. You can use U-substitution or not. All right, so let's define the chain rule. Or I'm going to give you a very basic description. So the chain rule basically says you're going to differentiate the outside function while the inside stays the same. Then you're going to multiply that result by the derivative of the inside function. Just to show you what I'm talking about one more time, and I believe this is in the book, if you have f of x, which equals g of h of x, then that means that f prime of x will equal the derivative of g, h of x stays the same, and then multiply that by the derivative of h. So kind of another way of looking at it. Okay, so let's do an example. Or let's do one out of your book. Let's actually do, let's do number 13, because this is a good one for me to remind you guys of something. So I'm going to do number 13. This is page 105, I believe. Okay, so number 13 asks for you to take the derivative with respect to x of cosine to the 4th power of 7x. So that's how it looks in your book. And there are many ways to rewrite this. So the first thing that I would do is I would remember that if I raise cosine to the 4th power, that's the exact same thing as, and I'll rewrite the derivative, but it's exactly the same as saying, well, this is cosine of 7x, the whole thing raised to the 4th power. Okay, so now this allows me to think about, hey, what's my inside function and what's my outside function? And actually here we have a couple of inside functions, because really my outside function, this is my entire outside function. It's something raised to the 4th power. Okay, and then that something raised to the 4th power, inside that it's a cosine function, and inside that is 7x. Okay, so I'm going to, if I wanted to use U-Substitution, well, let me do this two ways. So the first way that I look at this is I just say, well, I need to bring this 4 down, so I need to use that power rule. Okay, so I'm going to bring the 4 down. Now everything else stays the same, so this is still cosine of 7x raised to now 1 power less, 3rd power. Okay, so I just did the outermost. Now I need to take the derivative of this inside piece, realizing that I have another inside piece here. So the derivative of cosine of whatever this is going to be negative sine of 7x. So I've just taken the derivative of this inside piece here. But now I also need to take the derivative of my inside piece. Okay, and so the derivative of my inside piece is 7. All right, so when I multiply this all together, let's see, I've got a negative 1 here, a 7, and a 4. That's going to give me negative 28. And then I don't think it matters which way I do this. So how about I do cosine of 7x cubed times sine of 7x. Okay, so now let me do that using U-sub. So here's the U-sub way. All right, so let's say now that my function really is, I'm going to take the derivative of cosine of u to the 4th power, okay? And I'm going to let u equal 7x. All right, then that means that du, or the derivative of u with respect to x, will be 7. Okay. So you still have to remember to use this chain rule, saying, okay, well, I know that I have this outside function that's being raised to the 4th power. So I need to handle that first. So I'm going to bring the 4 down, leave the inside alone, cosine of u. Okay. Now it's time for me to take the derivative of cosine. And the derivative of cosine is negative sine of u. Oops, this would be to the 3rd power. Sorry, I forgot that. It's a little bit late. Okay, so I just did the derivative now of cosine. And now I need to take the derivative of u, which is the innermost function. So that's going to be the derivative of u with respect to x. Okay, so I have everything I need now. Everywhere that I have a u, I'm going to go back and plug in 7x. And everywhere where I have a du dx, I'm going to go back and plug in 7. So I put 7x in there. 7x goes there. And then du dx was 7. And once again, I've got a 7 times a negative 1 times a 4. So that's all going to give me negative 28. And then I'll do the cosine of 7x cubed sine of 7x. So a couple ways to do the exact same problem. I think, let's do a couple more problems. So let's do kind of an easier one. How about we do another example? These are just some that I came up with. So we're going to find the derivative. Okay, so the first one, these will be a little bit easier than even the example I just gave you. 2x plus 3 raised to the third power. Okay, so we want to know the derivative. So the derivative with respect to x of 2x plus 3 to the third power. So ask yourself, what's my outside function? What's my inside function? So right now I see my outside function is something raised to the third power. So if you wanted to use u sub, what you could say to yourself is, let this inside function be u. Then the derivative of u with respect to x, well, the derivative of 2x is 2. The derivative of a constant is 0, so it would just be that. Okay, so I could really say, well, this is the same thing as the derivative with respect to x of u cubed. So when I take the derivative of something cubed, I bring down the 3. Take that power to 1 less. And then I would need to take the derivative of the inside, so that's times du dx. Okay, now I'll plug u back in. So u was 2x plus 3 times du dx, which is times 2. So this is really, if I multiply my coefficients, 6 times 2x plus 3 squared. Okay? Now, if they wanted you to, you could potentially multiply this out further if you needed to. So, just to remind you guys, this could potentially be 6 times 4x squared plus 12x plus 9. And altogether, I could end up with 24x squared plus 72x plus 54. There will be a time and a place. Sometimes you'll need to multiply it out. Other times you won't. Okay? So either one of these answers at this point is good. But in case if we needed to simplify it or combine it with something else, either one of these two will work. Now maybe you said to yourself, well, why did we have to change that into u? Why did we make that inside function u? You don't have to. So a lot of times when I do these, I don't use the U-substitution. I was taught that when I was in college. But I've been doing this for so long, I can see what the inside function is. Okay, so I want you to work wherever you're comfortable. So another way without using u that I could do this would say, well, the inside function is 2x plus 3. So let me start with the outside function, which is this 3. So I'm going to bring down the 3, and I'll leave the inside function alone and take it to 1 power less. Now I'll take the derivative of the inside function, which is basically 2. And bam, I'm done. And then I could distribute it, and I'd end up with the same exact answer. Okay? All right, so there's one. Let's do another one. How about, let's do, oops, we'll call this B. What if I just have you do sine of, let's see. Sine 7th, I'm making this up as I go, of 2x plus 1. How about 2x squared plus 1? Let's do that just for fun. Alright, well the derivative of this, and I would rewrite it right away so that I have the derivative of 2x squared plus 1, and I'm taking this whole thing and raising it to the 7th power. Okay, so for me, I'm going to look at this and say, well, my outermost function is something being raised to the 7th power. So the first thing I need to do is I need to bring that 7th power down, leave everything else alone, and then decrease this by 1 power. Okay, now I need to multiply that by the derivative of my inside function. Well, notice I have an inside function, which is sine, and then I have another inside function, which is in there, 2x squared plus 1. Well, the derivative of sine is negative cosine. That's not true. The derivative of sine is cosine. So I'm going to take the derivative of sine, I'm going to get cosine of whatever this innermost function is. 2x squared plus 1. And then from there, I now need to take the derivative of the innermost function, which ends up being 4x. Alright, so let's think about what I got here. I have a 7 times a 1 times a 4x. So that's 28x times sine of 2x squared plus 1 to the 6th times cosine of 2x squared plus 1. And there's my final answer. Let's try this now using U-Substitution. So I'm going to let U be this most innermost function. So I'm going to let U equal the 2x squared plus 1. So then the derivative of U with respect to x will be 4x plus 0, because right, derivative of a constant is 0. Okay, so let me rewrite this. The derivative with respect to x of sine, now instead of having 2x squared plus 1, I'm going to use U to the 7th power. I'll now take the derivative of the outermost function, so that basically means using the power rule here. So I'm going to bring the 7 down, I'm going to leave sine of U exactly where it is, because that's the inside function now, and then lower that to 1 power less, which is 6. And then I need to multiply that now by this derivative of this inside function here, which is sine of U, and the derivative of sine is cosine, so that's cosine U. And then I need to multiply that by the derivative of the innermost function, which is U, so that's the derivative of U with respect to x. Okay, so simplifying this all and plugging in or substituting back in what U was, this will be 7 sine of 2x squared plus 1 to the 6th power times cosine of U, which is 2x squared plus 1, times the derivative of U with respect to x, which was 4x. So you'll notice that gives me the exact same thing. I've got 28x times sine of 2x squared plus 1 to the 6th power times cosine of 2x squared plus 1.